Oh man. It was a bit queasy. Must have had too much carbonic acid yesterday.
Now, Morpheus wants to talk to you. I think it's something about a new mission.
Morpheus.
Hello, Neil. Please take a seat. Alright. We've got good news and we've got bad news. Which one do you want first?
The good news.
Alright, the good news is that Agent Smith and his allies are no more.
And what's the bad news?
The bad news is we got a new man on our hands. His name is Agent H+.
Agent H+?
Agent H+.
Agent H+?
Yes, Agent H+.
Might be the same Agent H+ that bullied me in high school.
Hey kid, give me all your protons.
No, you're not supposed to take protons. It's against the Bronsted-Lowry theory. They're in acid.
I don't care what some lame Schmooligans theory said. Give me your protons.
No!
I'll teach you not to mess with H+.
Hey kid, are you okay? I was over there and I saw you get beat up. I'm Morpheus, by the way. Here's some protons that I acquired earlier today. Check out. Ancient ninjutsu healing power! No, no. How about a band-aid?
Thank you.
Mm-hmm.
Thank you. Thank you, Morpheus.
Okay. Yes, that H+. Now he's using his acidic powers to corrode those in the Matrix. We must stop him.
How?
Tank and I have spent months researching his abilities and have found his one weakness. He can be neutralized very easily. Now we take this ability and we destroy him. Tank, run the fight system.
Gotcha. System initiated.
Alright, Neil. Fight with all you got.
Good. That might suffice against Agent Smith. But our enemy now is so much more. He is Agent H+. He is an acid. According to the Arrhenius theory, an acid is any substance when dissolved in water forms H+ atoms, which are carried as H3O+ hydronium ions. Now, according to the Bronsted-Lowry theory, an acid is something that donates a proton.
What does that mean?
I'm getting there. Hold up. We are the opposites. We are bases. When dissolved in an aqueous solution, we form OH negative ions, according to the Arrhenius theory. According to the Bronsted-Lowry theory, we receive protons.
Opposite?
Yeah, opposite. For example, when you mix an acid and a base, liquid water is formed, as well as a salt. Here, let me show you in the lab. Tank, run the lab demo.
I'm on it.
Alright, here we are. Tank will run you through the demo.
Oh, what's that white powdery stuff?
This is baking soda. Chemical formula, NaHCO3. Normally, we use this to neutralize any acid that might get on the table or ourselves. But today, we will be using it to neutralize vinegar. This will also be our primary weapon against Agent H+.
What about the other stuff? Antacids, I think. Why don't you use those?
Well, if you compare number of dollars spent to mole of HCl that they actually neutralize, you'll see that this baking soda is actually much more effective. For example, those Tums, the effervescent tablets, they cost a just to neutralize 1 mole of HCl. And the milk of magnesia, that costs just for 1 mole. Now, when you look at baking soda, this only costs for 1 mole of HCl.
So that's like times cheaper than milk and magnesium, 8 times cheaper than the effervescent tablets.
Yes, very good. This Arm & Hammer baking soda will neutralize any of your acids.
What is
Alright,
this?
this will come later. First, the acetic acid, HC2H3O2. We'll pour this in a cup. See, when this is dissolved in water, the acetic acid dissociates into H plus ions, hydronium, and C2H3O2 negative ions, acetate. Now this is cabbage juice. This is an indicator. Notice when we pour this into the acetic acid, the solution turns pink. That means this solution right now is acidic. Now here we have the baking soda. When we pour this into the solution, notice the bubbles. That is the carbon dioxide bubbles coming out of the reaction between HC2H3O2 and NaHCO3. This reaction will also yield H2O and NaC2H3O2. Also notice how this solution is now purple. That means this solution is more or less neutral, and the baking soda has done its job to neutralize the acetic acid.
Wow.